Consoles traditionally have been the easiest way to ship games in large quantities where there is very little piracy because of all the security measures that are built into the console itself. In our case, we built in a ridiculously large amount of security to make sure that these games don't get pirated. But it was critically important because this is our partners and our bread and butter. Microsoft makes money on Xbox One from royalties that we charge people to put their games on the console. Okay? That's where we make most of our money. Every single one of those games that gets pirated costs us money, and it costs our partners money, and we would like to avoid that if at all possible, because it's bad. It takes money out of both of our pockets. So having this kind of IP protection and making sure that we could do it in a way that guaranteed that everybody had a legitimate copy of the game, but also didn't go draconian the other way, which is keep people from playing it if they wanted to, right, was really, really important. And that was an interesting line to walk, because when we originally talked about Xbox One, one of the things we said was always connected. And always connected turned out to mean different things to different people, which is bad. Make sure when you're designing something that everybody agrees on what the thing you're designing is supposed to do would be a good first step. But it was important because we had to make sure that if we are going to always be connected and we are going to require licenses for these games to be updated at some frequency, we had to make sure that people didn't go in, have a 25-second hiccup in their internet from Comcast, and not be able to play their game. That would be really bad. So we spent a lot of time figuring out the IP protection, figuring out the optical disk protection that we had to do, and all of those things to make it so that it was viable to get the console done. That, again, drove a lot of operating system decisions and a lot of hardware decisions about how we were going to do everything. So we live in this world where I need an operating system that can do two wildly different things when you think about it. The first thing it has to be able to do is be predictable and powerful so that I can get these AAA games to run with as much of the console as we can give them. But I also need a world where I can switch away from that game really quickly to something like a Netflix or a Hulu or Bing or some other app, right? Having that other piece where I can switch away to means that that other piece is very unpredictable. I don't know what apps are going to be running in there 5 years from now, 2 years from now, 6 months from now. There's no way to know. I know what we're going to have at launch, but I don't know what comes after that. Right? So there has to be some way to know this one can be anything it needs to be, while the other one is extremely predictable and doesn't take anything away from the game developer. This turned out to be a really, really hard problem to solve with a single operating system. So in typical Microsoft fashion, we built 3. The first operating system that we have, the one that boots the console, the one that actually basically owns where everything and how everything works, is the host operating system, which is that green bar that you see at the bottom. The host operating system owns all the resources. It owns all of the memory. It owns all of the CPU and GPU. It controls all the controllers. It traffic directs all of the network traffic that's coming in or out of the box. And its job is to be the security layer, as well as to control all these resources. So the host OS is completely opaque to you as a developer. You never see it. It just works. It works really well, actually, which is awesome. But this is the piece where we put all of the eggs that control security and control resource management for the box. Part of what it is doing is it's also hosting what were 2 Hyper-V virtual machines. So the shared partition, or shared OS, or SRA side of the Xbox One contained an operating system that is visually and, in fact, code indistinguishable from Windows 8. So what's running on the shared partition right now is Windows 8. It just works, but it has a lot of other jobs to do besides just running apps. It can run apps, and it runs them very effectively, but it's also in charge of things that you can barely read there, which is the Xbox shell, or at least I can barely read it. Maybe you guys can see it better. The system services, okay, so this is all of the system services that games require to be able to run. The networking stack lives here. Some of the audio stuff lives here. A lot of the Connect processing happens here. And this particular shared partition, when a game is running, gets 2 CPU cores all to its own. It gets 3 gigabytes of RAM, depending on the modes that it's in. And the low-level operating system is here as well. which is basically the Windows 8 and kernel pieces that run that. So this thing is the first thing that spins up after the host OS. Your Xbox finishes booting. You see the shell come up. The shell really isn't anything more than an app that can run other apps. And it comes up, and now you are sitting at the Xbox One. The exclusive partition hasn't fired up yet. The exclusive partition fires up when you play a game. You say, I want to play Forza Motorsport. It says, fine. It spins up that partition, gives it all the resources it needs, says, here's Forza, go start running. And Forza takes off and starts playing. Everything that Forza needs below that either goes straight through the shared partition, whether it's networking or things like that, but there are other things that had to run way faster than that on the exclusive side in order to get the performance that we needed. Those things include things like the video driver, right? So when I'm issuing DirectX 11 commands to draw cars or to draw trees or to figure out what render target I'm going to use or to figure out what post effects I want to draw, all of those commands essentially go straight through the exclusive OS down to the host OS through a series of well-known channels, right? Which is why it's not a Hyper-V virtual machine anymore, and we call them partitions instead. These things would have run any operating system in the world that was x86 or x64 compatible. They don't anymore. They run the shared OS, and they run the exclusive OS now, and they don't do anything else. They're hand-tuned, hand-customized to make those as fast as is humanly possible. To give you some kind of idea, when we first spun up the exclusive partitions, when we first started doing this, we had a bunch of game tests, and those game tests would run somewhere between 5 and 10 frames per second, most of it spent on the CPU passing commands across that boundary. Over the space of running up to launch, we were able to get those so tight and so small that those games run at over 200 or 300 frames per second today. The CPU utilization is so slow, is so fast, is so small that it can run very, very quickly through those channels and do exactly what it needs to be able to do. This is critically important for these guys because they need it to be powerful and they need it to be predictable. So the exclusive partition also is running Windows 8. But it's a Windows 8 that has gone on a massive, massive diet. And in fact, diet is probably the wrong word. We certainly put it on a diet for a while, but then we got out the knives and the hatchets and the chainsaws and learned a lot about how Windows is interconnected with itself. That may surprise you and probably I shouldn't talk about, but let's just say that there's some places that didn't make as much sense as you might have thought. But the good news is we were able to get rid of all of it. And we have an extremely lean and mean operating system in there now, which is our other name for it, which is L&M. So on the L&M side, or the exclusive side, it's very, very tight. It's very, very small. We have all the Win32 APIs that were there, again, for games that are coming from Windows 7 or for games that are coming from other more PC-type targets. But we also have the WinRT pieces. So if you have a game that was running for the store, that was running for the phone, that you want to put in the exclusive partition side, it's relatively easy to port that too. All of the test games that I built for this run in both Windows 8 and Xbox One, even today. It has been trivially easy to keep them running on both platforms. It was easy to get them working on Windows Phone. It was easy to get them working in x64 on a Surface or an ARM. It was very, very important that we actually find out that this worked the way that we thought it did. So that's the operating system. Let's talk about unique features now, the hardware that we had, and a lot of the features in the operating system that are unique for game developers. For Xbox Prime, original, the first Xbox One, we made two big bets with that one in terms of cost, for sure. The first was a hard drive. This was the first console to ever have a hard drive inside of it that was there, guaranteed for every single one of them. That was a huge deal to gamers because it suddenly meant that all of your logic around saving and checkpoints and do you have a memory card plugged in and did you write down your 16-digit code went away. The gaming experience got significantly more seamless because of this hard drive. And that was really important because, again, that's what gaming is about. It's about seamlessness. It's about fun. It's about making sure that these people have fun when they're playing. The other thing that we could use it for is a content cache. Optical disk drives are not the fastest medium by which to read data off of. but hard drives are. And so we could actually cache, the games could cache their data to the hard drive. And when that data was cached to the hard drive, read it significantly faster than they could off the ODD, which was awesome, right? That let them have much better load times than they would have otherwise. The other thing we could do with it for the first time is have downloadable content and persistent storage for that content. Right? If somebody wanted to make a new costume for a game, or somebody wanted to make a new car for Forza, or somebody wanted to make a new weapon for Halo, they could do it now. And we didn't have to download it every single time you ran. We could persist it and put it someplace where we knew we could find it. Okay? That was extremely important because we also added an Ethernet port. And the Ethernet port was important, obviously, for multiplayer. This was our primary consideration when we built it. Xbox, the first Xbox, was about multiplayer. It was about live. It was about changing the way that we thought about consoles playing with each other to a world where they actually could play with each other. This was a very different way to think about it. But the cool part about it was that with Xbox Live and with the multiplayer stuff that was there, you could now play with your friends. They didn't have to be in the same room. They didn't even have to be in the same country. And you could still play with each other, which was just a revolution at that time in terms of thinking about how games were going to be put together. But it also provided a mechanism for downloadable content to be delivered, because we now had an Ethernet port where we could bring these things down. When we went to the next Xbox, Xbox 360, we decided to change our thinking about live quite a bit. If you wrote a game for the first Xbox, that game had to understand live itself. You had to write code to log in. You had to write code to get their profile, write code to do all of the things that you would think the box would already know how to do. And we didn't have time to do that with the first one. 360 from the ground up we decided was going to be live enabled. You logged into the console. You did not log into a game. The console managed your live profile. This was a very, very different way of thinking about it, and game developers loved it because they could just ask the question, who's logged in, instead of having to write all the logic to try and get somebody logged in. The dashboard and shell on Xbox 360 evolved dramatically over its 8-year lifetime so far. For those of you who remember, in 2005, there were 5 blades, is what we called them back in the day. And they did such exciting things as let you set up the console, decide what your resolution your TV was going to be, maybe type in an IP address for your internet connection. There was one that would also work if you plugged in your iPod to play music, and there was a Media Center extension in there that would let you play from Windows Media Centers if you wanted to. But that was it. And you never saw this thing if you put a disk in and closed the tray, or a disk was in when you powered up the box. The only time you saw that shell is if you powered it up and there was no disk inside, or if you hit the little Nexus button and went back to go figure out what to do. Okay? That has evolved from that very simple thing to where we are today, which is a hub for entertainment. All of your videos, all of your music, all of your gaming-related things, the Xbox Live indie game things, everything that we came up with that we thought would be cool to put into the Xbox 360 ecosystem is now part of that shell. And that shell is an incredibly rich experience. All of your games that you've bought are there. All of the music that you've bought is there, or that you listen to is there. All the video that you've bought or listened to or stream or whatever is there. And you can get to all of it through that shell. That was a huge difference. Suddenly this console went from being a purely gaming device to being something that was central to the entertainment in your living room. And we wanted to build on that with Xbox One. We also created Kinect. Kinect was a scary thing to build. Throughout the history of consoles, most things that you add on to a console do not do very well relative to the number of consoles that you sell. In fact, you're lucky if you can get 15 or 20% of people to buy something that you've added on later on. Kinect's attach is somewhere between 60 and 70% today, which is unbelievable given an aftermarket device like this. So it's obviously popular. It created an entirely new class and genre of games, whether they were dance games or the ability for your child to interact with the National Geographic animal games that were done. Just a completely different paradigm and way of thinking about it. but we couldn't